Welcome everyone to another observability clinic. Today's topic, as you can see, GitHub, automating release validation with Dynatrace, with a special focus on SLO-based release validation to speed up your delivery. GitHub is one of the solutions out there that we see a lot of our users use to automate the deployments, besides other solutions, obviously, like Jenkins, GitLab, Azure DevOps, and so on. But today, I brought in one of my colleagues, Danny Braaf, who really shows us how to use the data from Dynatrace, the SLOs from Dynatrace, to automate the validation of releases, and with this, expand what GitHub pipelines already provide. Now, everything we see today, I think, are also, I know, are also applicable to other tools, but very happy that Danny is here to show us specifically for GitHub. Without further ado now, Danny, you take it away. I'm really excited about it because I know what's coming.
Hi, Andy. First of all, I want to say I'm really honored to be part of your sessions. I love the observability clinic and what you are doing here. And yeah, let's hop right into the subject. So yeah, we've come here today to talk about automating release validation with Dynatrace and GitHub. And in general, what are we going to learn today? So in this session today, you will learn how Dynatrace automated release validation integrates into DevOps pipelines / workflows to stop risky changes from being promoted to further stages and include validation results and root cause analysis in feedback loops, reducing the time needed from problem detection to root cause identification, and to provide all necessary information to approve a release to production in one overview. Before we dive deeper, I wanted to talk a little bit about what part of Dynatrace automated release validation is of. So Dynatrace automated release validation is a feature in cloud automation. Cloud automation is a module within the Dynatrace platform that connects all other Dynatrace modules to DevOps practices, bringing data and automation together to speed up your software delivery by automating the validation of your releases. This helps our customers shift left and bring automated SLO validation to dev, to find problems as early as possible and provide developers with the insights needed to identify the root cause of the problem. If our SLOs are met, the change may move further in the pipeline. In staging, we consolidate test results with performance, infrastructure, and security scanning results to then be included in the staging release validation, providing the release manager with one overview to approve releases to production. If our SLOs are met and the release approved, the change may move further in the pipeline. Before the change is deployed to production, we run another SLO validation to see if our production environment is ready to be deployed into and to prevent failing releases because of resource shortages. If our SLOs are met, the change may move further in the pipeline and be deployed to development. After production deployment, we run one last SLO validation to ensure that everything runs as expected. Before we jump right into the live demo, I would like to point out that only 3 steps are needed to implement Dynatrace automated release validation into your infrastructure. We need to install a Dynatrace One agent or our agentless alternatives that we offer, such as OpenTelemetry or the connection with Prometheus. Then, as second step, we need to define our service level objectives that we can do either via dashboard, that for everyone that likes to use a user interface, or YAML for developers, for example, who don't want to leave the integrated development environment. But also thinking further of scaling, because if you're going to add automated release validation to, let's say, more than 2,000 or 3,000 apps in your enterprise environment, you want to have a way to easily define it, right? So there, it also makes sense to define that via YAML and include that in your GitOps practices, for example. Then all there is left, we need to trigger 2 API calls. One to start the validation, so run the validation, and the second one to get the results. Then After results, we can make an automated decision, right? If everything is all right, then there's nothing to do. We can just move further in the pipeline. But if the SLO validation fails, that's where we can react. That's where we can put in some remediation steps, such as maybe a rollback, maybe, or even very important is to provide a feedback loop back to development and to operations, anyone involved in the team, that something has gone wrong. And since Dynatrace has all the data to actually dig down and find what went wrong, we can provide the information right away and shorten the time needed from problem detection to root cause analysis. But let's look at all of this in a demo. We are currently looking at the release validation trends dashboard. That gives us a good overview of the SLO validation of all our stages. In this example, we are using 3 stages: dev, staging, and prod, which of course in your environment could be different. That doesn't make a difference. Like I said, automated SLO validation can be easily integrated with 2 API calls, right? So if you have more steps, you could add it to more steps if you wanted to. But to keep it short, here we are using 3 stages. And if we have a look at this dashboard, this provides us with some really valuable information. Right away, we can have a look up here if we start on the left-hand side, and we see a tile that shows us the vulnerable processes. And this basically shows us if any of the open security issues that we have here in our environment. As we see right here, we have 2 high security issues and 1 medium security issues. But in today's world, the question is really, do these issues have any effect on my processes, of the processes of the applications? Thinking of, are these processes connected to the internet? Are they available to be hacked, right? So in this situation, we see, yeah, we have some open security issues, but none of them affect any of our processes. So that's basically what we're seeing over here. One beneath, we have our host health. Then I'm going to hop right back up to the top here, almost in the middle. We have the latest evaluation of our SLO target in development. So here we see that our latest evaluation has reached 100% in SLO target. Next to that, we see the same for staging. And we see here we did not reach 100%, but 76.9%, which in our scenario is not enough to actually pass the change on to the next stage. The minimum we have set here is for SLOs to reach a minimum of 90%. Anything below 90% will not be promoted further to production. Then we look here to the right, and the latest SLO validation, so from the latest deployment into production, has met an SLO target of 100%. So also great, of course, in our production environment. Below that, we actually see also for each environment how many times within the given time frame of the dashboard. Up here, we're looking at 10 hours. The validation has failed for each stage. So here, for example, we see that we had in dev, the validation failed 2 times. Looking into staging, the validation failed 3 times and was able to pass 5 times. While in production, of course, the way it should be, we had all our validations passed. Below that, we actually see the current version that's deployed in our environment. So here in dev, we currently have the build version 460 with, like we said before, 100% target reached. And here in staging, we have build version 458 with also 100% of target reached. And that is the same we have in production. So if we look at this, what does it actually tell us? It tells us that we had a build 460 that made it past development and was automatically deployed into staging, didn't reach the actual SLO target that we need as a minimum, and was automatically rolled back to the last working version, which in this case was version 458. That's why that differs at this point and is the same version, latest version that we have deployed to production. Below that, we see the entire history of our releases and release validation score over time for each stage and moment in time in the past. Next to that, we see the same thing basically in a chart view to identify trends. So let's say if we recognize that too many SLOs are failed over a certain point in time, this would show us where we might need to invest to change that. So, right, that would also show it if we have a lot of fails in development, or if we have it in staging, might be different where we have to invest. Then, if we look over to the right side, we have the Smartscape overview, which shows us the processes, right? Gives us an insight into the Smartscape view of Dynatrace. Below that, we see the performance over time, and then the service health. Basically, right, what this dashboard is telling us right now is what I've said before. We've actually had failed SLO validation, which means somebody should have been informed about this problem, right? We will hop right into that scenario, but before we actually do, a quick look here in Dynatrace, what our application is actually runs on. So we're going to open the view of our Kubernetes cluster, and we can see here we have a Kubernetes cluster for all of our environments. If we go down here, we've separated here the environments into namespaces. So we have an own namespace for development, an own namespace for staging, and an own namespace for prod. Just to show you here that we, of course, have all that available to monitor as well in Dynatrace, and to give you a little bit of insight of what type of application we're going to be working with. But now, at this point, what I always like to do when I demonstrate something is I really like to demonstrate it out of the point of the view of the person who's going to be using it, or who has a value from actually implementing a certain solution, right? So at this point, we hop into the role of a developer, and we're going to have a look at our project dashboard to see what we have to do today. For this example, we're using a GitHub project, but this could just as well be Jira or a Rally, for example, right? Any tracking tool pretty much. And here we're using GitHub. And as we can see, we here have different columns and phases in terms of our project. So we have the to-do list, right? This is something we have to work on. We see what's currently in progress. We have a stage that's here ready for review, basically meant for the person who has to, let's say, review a release to approve it to production, right? That's where anything that would need to be reviewed shines up. Then anything that's done comes over here, and anything that's shipped and is ultimately released to production shows up in the shipped column. Now you can see here that we have different labels, and this is just one of the first little things that SLO validation provides you with, right? So for example, if I wanted to see all failed validations that I've had in the past, I can simply click on that label. And if we look over here, I see all my failed validations in the past, right? And also would have a system of record that's non-technical, I would say, right? And then in the same way, we can also look at everything that has passed, and logically everything that passed and then passed the staging evaluation will also make it into production. So the first really nice thing here, I would say, to categorize within your issues. But what we said, right, we're going to hop into the role of a developer. So let's think we are a developer. We just came back from lunch. Before lunch, we actually committed new code to our application that was automatically deployed and then validated, so that we come back from lunch, as we don't need to view as the automation runs, right? That's what automation is for. It does everything automatically. We get the answer if our code was actually validated successfully and was able to move further through the pipeline. And here we already see in our to-do list over here that we actually had an SLO validation that failed with only 76.9%, right? This is the same thing we just saw in the release trends dashboard. To look at everything that was included within this build, we can just click on the build number, and we can see here we had a deployment to dev, and in dev, the SLO validation passed, while when it was deployed to release and we had some advanced testing going on, I would say, some additional testing, that's where everything failed. And right now, this is a pattern. Why did it not fail in dev, but it failed in staging, right? On one hand, good that it didn't make it to production, but what is the actual reason that it failed? And this is the big value, I would say, for developers or even support and operations. Having spent some time myself in the beginning of my career in support, I know how much trouble it can be to actually find the root cause of a problem, right? And this is what we want to make easier. So first of all, we automatically open an issue if the SLO validation failed. Here we can see the headline. If we click on it, we get an actual link to the SLO validation dashboard. So if we open that, we here immediately get an overview and see that there are some things red and some things green, right? So let me walk through what it actually is. Over here, the big number is the main SLO target score that we have reached with 76.9%. This is made up out of all the green tiles that you see over here. Just as, for example, the process CPU usage, the host CPU usage, the host memory usage, response time for performance, disk queue length, throughput, and of course, vulnerable processes. Again, right? We want to know if there are any security issues or any security issues have effect on our processes as we move them through the pipeline. And below that, we also see our functional test cases. So that's also something that can be included in these SLO validations, which I will go a little bit further into in a moment. So here we see actually immediately what the problem is, right? Our host CPU usage was above the defined 40%, and our host memory usage was above the defined 30% with 75.69%. So there was something, right? Here's the big question. What actually caused this situation? Was this really caused by the changes that we made, which, you know, is strange if that problem, why didn't that appear in development when we had a validation, right? First, because functional test cases that we have in this stage that we don't have in development actually showed no problem, right? Then the second question, was there maybe an outage of our cloud provider that is running into this situation? Or is it an infrastructure problem? Do we have to have more CPU and more memory on our infrastructure, right? These are all these questions which now we have to find out, right? So from here, if I'm a developer, really simple for me to see what the actual problem is. And now I have to look what the root cause is, right? And here of course, I can go into all the Dynatrace features. They will get me into that information fast as well. But we also have an AI that helps us with that. So why not have a conversation with our Davis AI and see if our Davis assistant has found anything. I am going to open the chat in Dynatrace, but this can also be integrated into your enterprise chats such as Slack or Microsoft Teams, for example. So I'm just going to have a simple conversation with Davis and ask were there any problems within the last 4 hours. And Davis actually brings me back an answer with 2 problems that happened, right? So now I have to know when the actual test was, and that was actually the last one up here. And we can see here there was a problem called CPU saturation. If we have a look at the problem overview, we can see here that we actually went up to 100% CPU usage with 0 affected applications, 0 affected services, but one affected infrastructure, which is of course our host. Now, this might not have an immediate effect on our application, but it will at some point, right? If it starts with infrastructure, at some point the service running on that infrastructure and the applications on that infrastructure are going to run into issues. So better for us to solve that as fast as possible. If we click over here, we get a hint where we can find more information about the problem. So we click on the actual host. We can see here we open the overview in the actual time frame when the problem was detected. And if we scroll down, we can already see right here that what was most used here was, of course, the CPU saturation. Now, if we want to know what actually consumed so much CPU, we click on consuming processes. And up here, we can immediately see that we had a process called stress that actually used 79% of our CPU during this time frame. If we have another look at the memory, right, because we had a memory problem as well, we can see over here that also the stress process used 9.3 gigabyte of our memory. So it created the memory problem as well. So what is actually stress? Stress is a tool on Linux that you can use to stress test environments, right? For some reason, during our test and staging here, the stress process ran. This is surely not part of our test portfolio. So we now have to go back and find out who actually ran this in our staging environment while we were doing tests, right? So now we found out the problem that this was all about, and we now, of course, have to fix it. If we go back into our project overview, we can now, right, since we actually identified the problem, we can say, right, we reach out to everybody in the team and say, hey, make sure that you don't do that again, because that actually messed with our releases. And this is an environment where we should not run any stress tests unannounced, right? So, okay, we solved this problem and we can move it, the issue to done. And we can actually commit our code again, because there was nothing wrong with our code. But let's take the next step, right? Let's change something. Let's not commit something without making a change over here. And we can see we have another issue in our to-do list. Our security admins have tasked us with updating Node.js in our application. If we have a look over here, we can see the actual message. We are currently using the image node 1222 with 660 vulnerabilities, 13 of them critical, 58 of them high, and 50 of them medium, and 539 of them low. The suggestion is to upgrade to node 16.4.2, which has 441 vulnerabilities, 4 of them critical, 27 of them high, 10 of them medium, and 400 of them low. Now, this is the dilemma that we are often stuck with modern application software delivery, right? Now, it can always be that there are new security issues found for which there is not, that have not been solved yet. And this is exactly the situation that we're dealing with. And the question now that we need to ask is not, do we have vulnerabilities, but we need to ask, do these vulnerabilities have any effect on the applications that we're running? Again, like we saw before, is this process, does it have a connection to the internet, or can be reached from the internet, and so on, right? So often a situation, right, we like to think of just upgrade to the next version, there are no problems there, but this is the reality, right? We're stuck with that, we still have problems, but we need to find out if these problems have any effect on our application. So we go back and we actually take the issue, manually put it into the state in progress so that nobody else starts working on it. And we start solving the problem by going into our repository. In our repository, if we have a look, we have 3 branches over here, the master, dev, and staging branch. The master and staging branch are protected. We're not allowed to make changes there because everything that we change in our application has to go through the full testing stages. So changes can only be made in dev/feature branch, so to say, right? And now we go ahead and we make an update. Thankfully to Docker containers, this is quite easy, right? I just have to change the syntax over here, so give it the new version. So I change it from Node 12.5 to the suggested version of Node 16.14.2. Now, I forgot to say one part. We only looked at the security problems, right? But who tells me that my application still runs well, that my code still runs well with an updated Node.js version? Maybe there are things that are not supported, right? So we actually need to run through the whole test case portfolio. I'm going to commit this change. And in this, we are using GitHub Actions for automated continuous delivery. And the way it is programmed is that every time we push something to our dev branch, we automatically start the delivery process. What we're now going to do is we are going to deploy that into dev and then run our SLO validation. I'm going to go back to our project overview, where we find all the information that we need. And in a second, we should see an upgrade, and we got it here. So a new issue that has been opened for our deployment and SLO validation in development for build 469. If we look on here, we get a couple links. We get one link to the workflow monitor, which of course, usually it's automation, runs in the background. We don't have to actively view it, right? But for the sense of the demo, it's nice because we can see where things are actually at. We're going to also open the cloud automation link, which we will have a look at later. Now, in here, we see the actual workflow monitor. So the process of deploying our new committed code into development, where we first open a tracking issue, which is the issue that we've just had a look at, right, where we actually got the link to this issue. So important to have that always for tracking purposes. We want to make sure that we always have the right information on our dashboards. Then we built the container, right, transferred a new created files, the changes to the container, built them, pushed them to a container repository, and then our application can be deployed. And I'm going to have a quick look back into the PowerPoint. And this is exactly the workflow that we just looked at live. And just to explain it a little bit more in detail, what happens here, we at first created the tracking issue that we just saw before, right? Then we built a container, so a new version of our code that we then push to Docker Hub so that we have it available to then be deployed into our Kubernetes cluster. Next, we deploy the application to our Kubernetes cluster. And of course, this task also needs to wait until the application is actually up, right? Deploying alone doesn't make sense. It could be that it takes a half an hour until the application is actually up and running. And that's important so that the next phase, the testing phase, can start, for which in this example here for dev, we're using JMeter. And then after the test case has completed, we do the Dynatrace SLO validation from, as we can see here, the defined SLOs on the dashboard. That brings everything together. Once that evaluation completes successfully, so we've met all our SLO targets, we actually merge the dev/feature branch into the staging branch, which then kicks off the workflow that deploys the new code into staging and does the staging validation and so on. However, here we are using conditional execution. As you can see here, we have one task that has not been executed. That is a task that would only be executed on fail. So if actually we have a negative evaluation, so not 90% of SLO target reached, that's where then we would not merge the dev branch into the staging branch and create an issue similar to like the one that we just went through with the stress process. If we now go back into the workflow, we can see here We're still running the tests. This is a really short test case over here, right? This is for demo purposes. Of course, in your environment, these tests often run for hours or days, right? To keep in mind. But I don't want it to keep you looking at a testing stage for a couple of hours. That would be hard to keep everybody's attention. Yeah, so we've deployed the application. What's really nice with GitHub Actions is that you can actually paste links into the tasks when they're done. So we can actually have a quick look at the application, and we can see that the application built for 6.1 was successfully deployed to dev. Now, we go back and we see that the SLO validation task has started. This basically triggers cloud automation. And if we now have a look into our cloud automation interface, we can see here that in the evaluation overview, that the evaluation for dev has started. So this is basically our overview where we can see currently and past running evaluations in cloud automation. Here you can see this is currently running. So I'm going to switch over to an older task, the one that's actually from previously where we looked at the failed SLO validation. And this is the way it would look in cloud automation. So we have the stage, we have the actual overall release validation percentage. But also if we look over here, the different steps within cloud automation that are taken, such as the evaluation. And we have a really nice overview over here that actually shows us the evaluations over time. So here, if I open it up all the way, on the left, we have all single defined SLOs where you can use a wording of your choice, right? Here we have the host CPU, the host disk queue, host memory, and so on. Then down here, you can see the actual build number. And then, of course, here, depending, each of these SLOs have their own tile that shows us if they have passed or not, which up here we have the main validation score of 76.9%. We can see what actually caused that. As we already know, that was the host CPU and host memory. And since they did not reach the full level, this is exactly what was subtracted from the main percentage. If we scroll down, we can see actually how these SLOs are defined. So we can see here that we actually, for host memory, had a value of 75.6%. It has a weight of 2 within the validation score. Past criteria is that it's worth under 23%. Warning criteria is under 50. And it has actually failed with a score of 0. Below that, we have the host CPU, which has failed with a score of 7.69. And that is actually exactly what was subtracted from the main release evaluation score. And again, if we don't reach 90% for that, then the change is not allowed to move further in the pipeline. Now, interesting for this overview is also we don't just cannot just compare the current state, but for the sake of integrating continuous improvement into your environment, we can also compare with previous releases. So you can actually say that let's compare with these 3 releases in the main evaluation score, but also for each single defined service level objective, that it may not be less than a certain percentage than it was before, right? We always want to be better than the previous release. So let's say if you have quality initiatives going on, something like that, then you can actually use that to implement continuous improvement in your environment. Now we're going to go back to our workflow, and we can see here it has actually finished. The SLO validation ran right after our test case is completed. And if we have a quick look at the SLO dashboard, this is where we have defined the SLOs for development. We can see everything is green, everything is within the defined thresholds. And of course, most important, because of the upgrade and still remaining security issues that we have 0 vulnerable process. So the security issues that we have no effect on our application. We can also see here include things like JMeter test step executions. We can see here by step. We also have the performance over here, which also includes Dynatrace synthetic monitoring and synthetic testing capabilities. And yeah, of course, since we were able to evaluate the release successfully, it was allowed to merge automatically with the staging branch, and that triggered our next workflow. And to see what actually happened, let's go back to our main project dashboard over here. We can see the issue that we previously had for SLO validation in dev is done with the SLO evaluation passed, and a new issue was created for staging, right? And so here we now have the evaluation for staging, where we again have our links, and let's have a look at the workflow monitor again. This one differing a little bit from the previous workflow that I've shown, just because we have a more a testing phase that includes a little bit more than before. So we don't just have performance tests, we also have a functional test case portfolio that we're executing here. Here for this example, we are using JMeter, and also then Tricentis TestIM for functional test steps executions. Of course, we would also be able to include Load Runner at this point, or BlazeMeter, or whatever you may use for performance testing. And once these tests have completed, they then pass on the start and end time and tell the Dynatrace SLO validation, within what time frame it should be evaluated. And here we see a little bit of a different conditional execution that we had before. So what we have here is, if the SLO validation fails, we are not only creating an issue, we are also rolling back the application to the previous version, as we want to make sure that anything that is deployed into our staging or pre-prod environment, however you want to call it, is valid and has no problems deployed to it, right? So we can do an automatic rollback, and it's all based on the data that we get back from the SLO validation. However, if it's positive, again, what we are going to do, we then have a step in between. So it's going to ask for an approval. And if we approve, it's then going to merge with the production branch, and then start the workflow to deploy to production. Now I'm going to hop into the PowerPoint one more time. One last time, to basically give you a little bit of an idea of what we are currently looking at. So here I have a release validation integration example that has a very modern GitOps delivery concept to it, right? So basically, if you see, we have our 3 stages like we have now. When something new is pushed to the features/dev branch, automatically a pipeline is started that builds containers, deploys them to ephemeral environments, runs the dev tests, and then you have some kind of feedback and approval, right? A 4I principle. And we look if everything is all right. And if everything is all right, we merge the DevOps to the staging branch, which automatically triggers the staging pipeline, where we again can build fresh new containers, deploy those to staging, run our staging test case portfolio, and then again we have the feedback and approval. And then we usually have an approval step, right, from somebody who is responsible, maybe the release manager, maybe the QA manager, who can make that decision if a release is ready to be released into production. And once we merge with the production / master branch, we then deploy into production. Now, how exactly do we integrate here with Dynatrace? So we go ahead, and as we just saw, we run our first validation here right after the dev tests. So for dev to be able to get back feedback in case it doesn't work well at any time. Here, you could work either way. You can either use the SLO validation result within your 4i principle before you actually move the code on, or you can run it automatically after the 4i principle, if you have such a principle, right, to promote it to staging. So then what we're going to do in the staging part of the pipeline, here we're going to integrate again SLO validation after the testing phase, to then what most of our customers have is, of course, a manual process. Like I said before, the release manager or maybe the QA manager making a decision if a release is ready to be deployed to production. So basically here, what often happens is you have to dig piles of reports and Excel files and so on. It's a real nightmare and headache because, of course, the person who does the approval also takes the risk, right? We don't want to approve something to production that is not ready. Then what we are doing here next is the pre-deployment validation. So we want to make sure that before we deploy our no-code to production, that our production environment is ready to be deployed to. Thinking here of specific scenarios, some of our customers are in the banking sector, so in the financial sector, and absolutely still need to have some parts in the private cloud. Now, private cloud, right? If you've ever dealt with VMware before, the big problem comparing it to public cloud is really the limited resources you have, right? It still runs on the same x86. And what happens now with really advanced customers that have advanced automated pipeline is that deployments take away resources from each other, right? So you want to make sure that the production environment is ready to be deployed to not have your production environment fail. And then, of course, after the deployment is done, we run another evaluation, saving us any manual steps to see if everything went all right. So, of course, we need to be informed immediately if something went wrong after being deployed to production. Let's have a look back into our workflow. And we can see here that we've finished the test cases. We have here the SLO validation step. Let's have a quick look if everything went all right. We can see here we have everything in green now. Everything went all right. Also down here, again, we have no vulnerable processes. And in addition, we've also added a Tricentis functional test cases, right? And here we have an SLO defined of it's got to be in a minimum of 90% that's positive. Here with 100%, that's even better. So this is definitely not a blocker. And our code may move further in the pipeline. Now, let's think of this as out of the view of a release manager, right? I don't have to go through Excel files. I don't have to go to piles of reports. I can actually consolidate everything I want to know in one overview and automatically validate that. And maybe at one point, you are so confident with the validation that you would also do the approval to release automatically based on the release evaluation score, right? So this is basically all the advantages that we have. And you can see here it went on successfully and is now waiting for an approval. And if I refresh that, I also see the approval step, right? So this is basically what the release manager or a QA manager would do. I've now seen that everything is all right with this release. 100% of SLO targets reached, so no problem. We reviewed the deployment and we can approve to production. And once we've approved it, we can see here that our on success approval merge task will start, and it will actually merge the staging branch with our production branch and then start our production workflow. So we're going to see that in 1 second.
I hardly ever keep that quiet, Danny, because but it's just fascinating to see how all this works so nicely. And you brought up so many cool use cases, starting from the automated feedback start then going into, I really like that use case as well, validating that an environment A is ready, right? Pre-deployment checks, is the environment ready? The next thing, the first thing you actually showed was, hey, if something is wrong, maybe I'm not the reason for it, but maybe something else is going on in the environment because somebody's running another test. And this is why it makes so much sense to really have the full stack observability and then combining it and giving you the data about what is actually currently going on. And with all these integrations here, the direct links, the dashboards that you automatically get, it's beautiful, really cool.
Yeah, and I always think back of my time that I've spent in the beginning of my career in support, where we've sometimes spent days, even weekends, for urgent problems, especially performance problems, working together with dev and QA to actually find a problem. If I think about if we would have had this 12 years ago, it would have been so much easier and would have saved us so much time and headaches. Right?
Yeah. Now, Danny, I have one quick question, even though you mentioned in the beginning, this is great. This is GitHub, works with GitHub Actions. For those people that don't know GitHub Actions, obviously there's many actions out there where you can trigger external tools, like the way you integrate with Dynatrace is through an API call. But just as a reminder, if you're using different tools, the Dynatrace integration is just an API call away. So I'm pretty sure that can be done also with your tool, and ping us if you have questions how this should be done then. Yeah,
absolutely. So I've worked with many tools in the past, so I've also integrated this already into Azure DevOps. It also works with Bamboo. It also works with Jenkins. So basically anything out there that can trigger an API call, right? That's how simple it is to integrate into your environment. And one last step maybe, so that we just have a simple look. We don't have to watch it all the way until the end, but this is basically our production pipeline or production workflow, right? Through merging with the master branch, through approving the deployment to production. We are now again opening a tracking issue, so we'll see the information being deployed to production. We are running the pre-deployment evaluation, then again deploy the application and run the validation afterwards. Since we've now seen that a couple of times, I think we don't have to go through it again, but I'll show you that this is part of it, right? And if we now go back and look at our release trends dashboard, and what I also want to show to you in addition is now we've really gone through looking at everything a little bit in technical detail, right? Let's say if we're maybe an operations engineer, or we're a release manager, or we're a site reliability engineer, we might not always look that deep into everything. It's not necessarily within our expertise, right? So looking at Dynatrace dashboard, so also what I can do, which maybe fits a little bit more into the tooling of these personas, is to go over here, right, and have all that information actually in the release inventory. So here, if I select by management zone, I can see all the releases that I've done. So here we've had the release that we've just looked at in staging, same in dev. And if I click on it, I can also see the deployments. So here we've had 2 deployments, so 2 replicas. That's why it's 2 deployments. We've deployed 2 replicas, and if we open that, we can see we have all the information that we actually need. We see the entity, we see when it was deployed, we actually get a link to the workflow that has done it. We get the commit message, we get who has changed it, we get the project URL, and we also get URL to the tracking issue and see the release validation score as well. So you don't necessarily have to go through all this, what I've just shown, to get that information. So in Dynatrace, you can also get it within the environments that you're used to.
And Danny, I think the big point here is if you click back in the breadcrumbs to the releases, to the overview of all the releases that you have.
Yeah.
I think the big benefit here is, while you have shown GitHub today, in large organizations, as you scale, you may have different tools where you deploy. You have GitHub, you have some Jenkins, you may have some other ways of deploying. So one of the things that I like about this is that you have a consolidated view of everything that is deployed by any type of tool, and also with the link back to the individual tool without you having to go to these tools to actually get all of this information, right? And
Yeah.
the other thing with these, we call them release events here. You have deployments. There are also other release events that we can track, like configuration change events if you turn on or off a feature flag. Anything else, the point here is also that if a deployment, if a release, a configuration change is then causing a problem either within that app or maybe within that platform where other apps are running as well and having a cross-site impact, Dynatrace would show you that this particular release event is the root cause of a problem, pointing it back to the tool that deployed it, the person that deployed it, the pull request, and maybe Jira ticket or whatever it is. And that's for me, the phenomenal piece about this here, bringing it all together.
Absolutely. I absolutely agree. And think about it, if you run into a situation and you have a government audit, right? That's in Europe, we have GDPR. So let's say, there is a security breach. And what you will have to prove is that you've tried everything to prevent this, right? And here you basically have your entire history that will help you also deliver the right information for these audits as well, right? And yeah, that's basically it. So I'll go back to the PowerPoint and go to the next page, and we have come to the end.
Yeah, exactly. So Danny, first of all, thank you so much for this. I know, as I said, I hardly ever keep that quiet for that long, but it was just a pleasure to watch you do all this. Even though I've seen it now the third or fourth time, it's just amazing.
I hope it was not too fast a little bit, but
not at all. The thing what I want to highlight, folks, if you're watching this and if you have questions, you can probably easily find us on social media or on the Dynatrace community, community.dynatrace.com. Go and reach out to us. If you want to try this yourself, give it a try, right? If you need some help, again, reach out to us, or also use the in-product chat in Dynatrace to reach out to your Dynatrace experts. If you're not a Dynatrace customer yet, but you are interested in this, well, then start with a trial and then take it from there. Phenomenal stuff. Again, thank you so much. I'm sure there will be more of this with you. See you next time.
Looking forward to more collaborations, Andy. Thanks so much for having me.
Thank you. Bye-bye.
Take care.